You could take an entire class about application vulnerabilities and learn about all these concepts and terms. I'm just going to run through these real quick and just kind of give a brief example of what they are. But like I said, you could take an entire class about this, and I highly recommend doing so. If you haven't taken an IT security course, it would be a good idea to take that. You really have to have that foundation of IT security to do cloud security anyway. But it's a good idea to kind of understand a little bit about how these different vulnerabilities affect your applications. And a lot of these aren't just applications, but they're especially concerning in the context of applications. One of those is injection attacks. A classic example of an injection attack would be something like a SQL injection, where you can, let's say you're filling out a form online and you know that there's a database that is used by an application after you fill out that form. You could put SQL code into that form and hope that it gets executed by the SQL server. So that'd be an example of an injection attack. There's other types of injection attacks. You can do injection attacks with JavaScript. You could do it with XML. You could do injection attacks that are directory traversal attacks and things like that. So just basically what you're trying to do is take advantage of the fact that the web server has to accept input from the web and process that input, and you're hoping that you can somehow trick the application by providing some input that it doesn't sanitize, and it executes some code that it didn't intend on executing, whether that's JavaScript or even if it's a CGI-based application, maybe even just uncompiled code that might be able to run. For example, if they use Perl or Python or something like that in their application with CGI, then maybe you can inject that type of code. So that's basically what injection is. The number one protection for injection attacks is to sanitize your input. Most web applications and but the reason I keep saying web applications is in the cloud, the vast majority of our applications are probably going to have some some connection to the web if they're not web applications themselves. But broken authentication and session management is another issue for applications running in the cloud. So we have to do authentication somehow. And most of you probably use applications on the web like Facebook or something like that. And you might notice that when you log in to, say, Facebook, for example, you don't have to log in constantly. Once you log in one time, you're logged in for a long period of time. You very rarely have to log back in. They do that to, because it's a better user experience, and most of us would get annoyed if we had to log in every time we refresh the page. If we didn't have some kind of session management mechanism, then we wouldn't be able to do that. Web properties like Facebook wouldn't be able to have you authenticate one time and then have it work for weeks, it seems like, after that on your computer. So the problem is you can hijack those sessions. You can take advantage of flaws in how that session management works. And a lot of these session management mechanisms are not that complicated, and they can be hacked. They can be compromised. So that's another vulnerability to look at. Cross-site scripting is a vulnerability that usually involves, it's very similar to injection attacks, but you're injecting code into usually into some kind of form or into a URL or something like that. That's going to get executed by the web server. Cross-site scripting attacks usually take one of two forms. They're either a reflected or a persistent attack. A reflected attack is where a user or an attacker puts some information into a website and it gets reflected back to them. How would they use that? You could perhaps send somebody a URL, a RESTful URL. So for example, if I sent you guys a URL where it has the parameter to do a query for cloud stuff, when you click on that URL, it would just bring up clouds. But what if I put something more nefarious in that search term? So when you clicked on it, it brought up offensive material or something like that. That might be an example of a reflected cross-site scripting attack. Whereas a persistent attack is when you're submitting some code to a website that is going to persistently reflect something to the user. So in other words, a reflected attack only affects the person that is clicking on a link or is going to that website using that attack, whereas a persistent attack is anyone who's going to that website can see the results of that attack, such as if somebody's defacing a website. That's typically a persistent cross-site scripting attack. So once again, sanitation of input is the best way to protect against that type of vulnerability, but it's important for us to know that that it does exist. You have insecure direct object references. So for example, you can have references to objects from a web-based application that is exposed to users so they can do reconnaissance either on those objects or they can access those objects directly. So I'll give you a good example of that. I have a web-based application that I work with in one of my lives in one of my professional lives, and it's for viewing medical image data. And using if you were to take something like Wireshark and run it on a computer that's running this web-based application, you would be able to see the AJAX calls back to the web server looking for specific image objects, and it calls those objects using their global unique identifier. But what if you just started making up global unique identifiers and seeing if you could pull those objects? Well, if you happen to guess the correct object identifier for a real or existing object, then you would get a file that maybe you're not supposed to have access to. So that vulnerability would need to be patched by having some authentication mechanism layered on top of the access to those objects. So insecure direct object references is when somebody can access that object directly without having to authenticate. And the idea is that it's protected through obfuscation, because who would know that exact identifier to pull an object? But that doesn't mean somebody can't guess if they can figure out the mechanism that's pulling those objects. So that's a good example of that. Security misconfigurations. Sometimes, if anything is not configured correctly, it may expose data, for example, which leads to sensitive data exposure, which could happen through any of these. Missing function level access control. So you might have functionality that is lacking access control, so an attacker might figure out how to use that to get information they're looking for. Cross-site forgery, using components with known vulnerabilities, maybe not on purpose, but maybe we just happen to have those vulnerabilities. For example, the Heartbleed bug came out years ago, but there are still web applications out there that if you scan them still have those vulnerabilities and are known to have those vulnerabilities. People just don't update and patch a lot of these applications, so we want to be diligent with those types of things. And patching, of course, is one of the great ways that we can reduce these vulnerabilities. Invalidated redirects and forwards. So, for example, you can have web-based applications and APIs that have redirects and forwards that redirect users or forward users to other resources. And maybe you assume that the only way somebody would land on a certain web page or something like that is because they were redirected or forwarded there from somewhere else. But it is possible for people to stumble across those things. And there's plenty of cases where sensitive data has been released because it was placed somewhere on the public web, but because it had such a complicated URL and no one thought anybody, maybe the search engines were set, the hint in the header was there to tell the search engines not to index it, and somebody just happened to stumble across it somehow, right? Maybe through a typo or maybe just by doing some scanning or whatever. They might stumble across that information. So those are just some examples. When we look at vulnerabilities, when we think about vulnerabilities, I just talked about all those different things. I'll go back to the previous slide. There's so many different things we have to worry about with vulnerabilities. This is just a short list. I mean, there are so many things that we can make us vulnerable with web applications and applications in general. How do we manage that? How do we discover these vulnerabilities and work with, trying to harden against these vulnerabilities, whether that's a web-based cloud application or even applications in our own infrastructure, which of course is less concerning because there's not usually that direct connection to the internet. But one of the ways that I like to approach this is using some kind of framework. And one of the most common frameworks is Nist 853. So Nist 53 is probably one of the most common frameworks for IT security. It's referenced by many other frameworks, and it's also referenced by lots of regulations and laws and things like that. Basically, 550 or 853 is the Nist guidelines for doing business with the federal government or having secure systems within the federal government. So if we take that framework, we can apply it to pretty much any system. The government is nice enough to create this framework for themselves, but it's the government, so they have to give us access to these things. So we can use that framework. So there's a framework core, which defines how to identify, protect, detect, respond, and recover to threats and vulnerabilities. And then the framework profile, which aligns activities with business requirements, risk tolerances, and resources. And then the implementation tiers, which is where you are with the approach. Good grief. What does that mean in English? So what it really means is that if you look at the Nist framework, you want to use it to describe your current cybersecurity posture. So it'll help you. So basically in the framework, you can walk through all of these different functional areas, and you can use that to assess your current posture. And then you can use that to figure out what you want your target state for cybersecurity. You know, this is where we are, this is where we want to go. And then identify and prioritize the opportunities for improvement within, within that context of the framework. Assess your progress towards that target state so you can go back and revisit and make notes on where you are as you work towards that security posture that you're targeting, and also communicate among internal and external stakeholders about the risks. In other words, Nist gives you not only is it a good framework, but it has a lot of supplemental information that can help you describe these vulnerabilities and threats and also legitimize these vulnerabilities and threats. Sometimes when I'm in meetings, I feel like, when I'm not in meetings with IT security people, I feel like I'm the guy with the tinfoil hat talking about all these things that can go wrong, and being able to reference frameworks that are widely accepted and well written and understood, it helps legitimize some of the things that I'm saying. It's not just me being paranoid, for example. I know that sounds silly, but that's sometimes what we have to deal with. So the framework has lots of parts, but here's, for example, in section 2 are software platforms. Section 3 is communications and data flows. 5 contains information about hardware, devices, and data, and then asset vulnerabilities and impact analysis. So these are some of the sections that you could use to look at your vulnerabilities and assess your vulnerabilities and try to define what your security posture should look like as you go forward and give you a roadmap to do so.